So let's talk about the first module, next generation and security platform and architecture. So basically Palo Alto divides into two different planes, data plane and control plane. Okay. If we divide Palo Alto into like segments, so there are two different planes. The first one is the data plane. Data plane. And second one is the control plane. Control plane is there to like for all the policy configuration, all the things like if you configure something, it is going to be happen here in the control plane. Data plane is basically used to process the data, real stream data, like when your user trying to access the internet, right? That traffic will move from data plane, okay? But the policy which you configured for that traffic to move out will be configured here in the control plane. All the policies, NAT configuration, all the things will be done here in the control plane. If there is an other device, the HA synchronization will happen in the control plane. Okay. Apart from that data processing, all the configuration part will be done here in the control plane. Let me show you. Yeah, here it is. So Palo Alto is divided into two different planes. The first one is the control plane. The second one is the data plane. So data plane is used through traffic, means to pass the traffic from the Palo Alto. Getting my point? It is your real stream data. For example, you are accessing facebook.com, right? That facebook.com is your real stream data, that payload data. That data will pass through the data plane. Okay. Now the control plane, it is used only for that is used for the management responsible for HA, session synchronization, logging, signature updates. All the things will happen in the control plane. Good. So Palo Alto is basically divided into two parts, control plane and data plane. So in the control plane, all the things happens, all the management kind of configuration, all the it is responsible for the HA synchronization, session synchronization between both the devices, logging, signature updates will happen in the control plane, and data plane is basically used for to pass the data from one interface to the other interface. Okay. And this is we already discussed about. Palo Alto works on its own operating system, which is known as PAN-OS, right? By default, ping, SSH, and HTTPS are not allowed on the data interface, but by default, ping, SSH, and HTTPS are allowed on the management interface. Palo also is a zone-based firewall. We have to create the zone. If we want to communicate from one zone to another zone, we have to configure a security policy for that. There is one more line which is written as traffic is always unidirectional from source to destination, right? Traffic is always unidirectional. Means what it means, like let's suppose it's a firewall. One request is coming from this side and one request is moving from this side, right? So it means traffic will be unidirectional always. Someone will initiate the traffic, right? Someone will initiate the traffic will hit the Palo Alto firewall, and then all the security policy like the policy we configure on the Palo Alto firewall, that policy will be implemented on the traffic, After filtering, that traffic will move out from the firewall. So it means traffic always unidirectional from one location to the other location, from source to destination. So traffic will be unidirectional always, but there is an option you can put, like earlier we just talk about, like from one zone to the other zone, right? We talked about the security policy from one zone to the other zone, but if, for example, there are two different zones here and two different zones here, we can bundle the zones for source and destination. We can map these two zones in the source, these two zones in the destination, so that vice versa traffic can directly move out from this location to this, from this to this. We'll see this, how it actually works in the lab, but this is just for the knowledge. We can map the source zones, like if we have multiple zones and we want to map two different zones in a same, like in a same source list, so we can, there is an option for that. But for testing, we'll map only single zone as source and single zone as destination. Good so far? Any doubt? This is just the basic knowledge of the firewall. It works on the PAN OS. It used the customized FreeBSD. It's a zone-based firewall. Okay. Interfaces should be configured to respective zone. We talked about this. We have to configure the zone and map the interface in the zones. The ping, HTTP and HTTPS service for data interface and for the control plane, right? Let's talk about the like deployment, virtual and cloud deployment, the module 2. Virtual and cloud deployment. As per you, like how much types of deployment can be done, if you know, like how much types of deployment have you seen? If you talk about a router, Cisco router, have you seen any virtual router in any premises? Any one of you?
This is about the SD-WAN. When we use SD-WAN, we use with Tela, and so it is like that, right? And Meraki. So there are also some virtual routers are there.
If we talk about the deployment, basically there are 3 different deployments. The first one is, we all knows, physical deployment, means the physical box we opt for, right? To get a hardware box in a package, then we have to install that device in a rack, and then we need to configure all the parameters on that box, that physical hardware box. This is the first one. The second one is the virtual deployment. Using virtual machines. Okay. Like in our example, like we are doing the labs on virtual environment. So this is the example for virtual machines. The last one is the cloud deployment. So what is the difference between the physical hardware box, the virtual deployment, the cloud deployment? Any idea? I make it simple for you. Physical deployment, the name implies its information. We'll get a hardware box. We have to install that box in the rack, and then we need to configure all the required parameters in that Palo Alto Firewall. And for the virtual deployment, it is similar to our lab. We are doing the labs on virtual environment, right? We don't have the hardware box. I installed that virtual machine, Palo Alto's virtual machine, on platform and doing the lab. Same in that way, we have to procure the virtual machine, means virtual, they will provide us the OVA file or any file, then that virtual machine file, we have to install that file on a server. Have you seen the UCS server, Cisco UCS server? Any kind of server where we can implement, deploy the ESXi? Have you seen this?
No, sir.
We uses ESXi server to deploy the SD-WAN devices like some virtual routers or other things.
Basically, there are different options. You can deploy that virtual machines. Okay, you can deploy that. Firstly, we need a hardware box again. Like in the first example, we got a hardware box, in a physical hardware box in the physical deployment. But here in the virtual deployment, it's that virtual image needs some platform to run, right? So the first thing is we need one server, that hardware box. Okay, we need again that hardware box, otherwise we cannot run that virtual machine. Second thing is we need, this is the you can say the hardware platform. The server is the hardware platform where we're going to run the virtual machine. But how we can run that virtual machine directly on that server? We cannot run that virtual machine directly on the server. So we need to create some virtual platform, you can say, on we have to configure ESXi, KVM, VMware workstation. Okay, these are the examples. Then third thing, then we have to install virtual machine on the platform. Now I'll tell you how it works. Firstly, we need to procure one hardware box. Maybe it's a UCS server. You can take the example of a UCS server. Okay. Then this is the first thing. We have to opt, or we have to procure one hardware box. Then we have to install one virtual platform, which may be ESXi server, the KVM, or the VMware workstation. Then we have to install that one. It's also a file. We have to install that file in that server. We have to boot that file in that server. Then it will create a platform for us. Then after, on that platform, we can run that virtual machine, that Palo Alto virtual machine. It's a layer 3 kind of thing. Virtual machine is running on that platform, which can be like ESXi, KVM, and VM. Okay, and that platform is like working on a hardware platform, which may be your Cisco's UCS server. I'll show you one example. You can relate to that. So this is my laptop, right? I'm running my laptop. So this laptop is acting as the hardware like support that server. So my laptop is acting as the hardware box, as a server. Okay. on that hardware box, I'm using VMware Workstation. How I can do that? Let me show you. Here is the VMware Workstation, right? So that VMware Workstation is running on my laptop. So my laptop is acting as a hardware server. You can relate it to the UCS server. Okay. And on the use on that VMware Workstation, I'm running the Palo Alto VM. This is the Palo Alto VM, right? So this is my laptop. I'm running the VMware Workstation application here. And on that application, I'm running Palo Alto VM. Understood?
Yes, sir.
In the same way, we can use the virtual deployment. We have to opt the server, hardware server, then we have to install the any like platform, which may be ESXi KVM VM, and on that we have to install the VM, actual VM of the Palo Alto. Okay. Not only for the Palo Alto deployment, if you are going for any other virtual deployment, the same process will work. You have to like use one hardware box. On that you need a virtual platform. On that you need to install that virtual machine. Understood? Any doubt?
No, sir.
Any queries in physical or virtual deployment?
No, sir. It's good.
Okay, let's move further. So the last one is the cloud deployment. Like if you talk about the real-time scenarios, so 99.9% you will see this kind of deployment, physical or virtual deployment. Or maybe somewhere you will see the cloud deployment. And how actually it works. Your box is not like physically or virtually present in your premises. That box will be somewhere on the cloud, which is managed by the Palo Alto team. Okay. You need to configure the policy directly on that cloud. You'll get a cloud access. Then you have to configure the policies, and your devices will be filtered from this cloud device. It is maybe somewhere on a cloud is nothing actually. It's like it's a data center. Have you heard the term cloud? Like GCP cloud, Azure? Any idea about what is cloud actually is? Anything?
Yes, sir. These are the virtual environments,
Have
you
you
can
heard
say.
this term cloud? Like cloud engineering. It's a boom for now, right?
So these are the virtual environments we create.
So basically cloud is nothing. Cloud is just a data center. It is similar to the data center, but that data center is on a different geolocation and you don't know where it is. They are just providing you the services. They are just providing you the services, and you don't know how they are providing these services, from where, at what geolocation that data center is actually present. They are just providing you the services like uh, on a like they set it up a server in a data center, and they give you the access of that server directly. Okay, you can directly access that server, but you don't know where they placed that data center and where they placed that server. But you are getting the services. It means you are getting the services, the required services. You can access that server and you can utilize the services of that server. You are having the full functionality. but you don't know where that data center actually present, at which geolocation that data center actually present. Okay, so this is cloud. So simple to that, there is a data center which is managed by Palo Alto team or maybe a third party vendor. They install the Palo Alto here in the data center and they gave you the access. Now all your traffic will move from your location to that data center to that Palo Alto firewall, and same way after filtering your traffic will move out, and same vice versa traffic, the return traffic will come to the firewall in that data center, and then return request will reach to you, to your location, to that user. Good. So these are three different type of deployment in the Palo Alto. Majority of the deployment is for the physical and the virtual. Okay, but cloud deployment, there is an option if someone wants to opt for that, but I have not seen the cloud deployment yet in my career. But physical and virtual deployment, like n number of deployments I have seen in the physical segment or in the virtual segment. But cloud deployment, if you talk about the cloud deployment, I have not seen anyone who opt for the cloud deployment. Okay. Any questions regarding the deployment part? How we can deploy the hardwares?
No, sir.
No, sir, it's good.
Guys, am I audible to you?
Yes, sir.
Yes.
Yes, fine. Guys, am I audible to you?
Hello, it's audible, sir? Hello. Hello.
Ashish, I think your voice is not coming to me.
No, sir, it's good.
Ayush, are you there?
Yes, sir.
Not sure why I'm not able to hear your voices. Just give me a second.
Hello.
Can you speak again?
Hello. Hello.
Let me start a video to check my that headphone is working or not. Just give me a second, right? I need to like change the headphones. I think that headphone is not working. Just give me a second.
Hello.
Hello. Yeah. Am I audible now?
Yes, sir. Are you able to
Yes,
hear
sir.
us?
Yeah. Now I can hear you. Not sure why. Yeah, I'm not. Okay. I thought I'm just speaking. Like there's no revert, or I thought like
No,
in the
we are
class.
reverting, sir. We are reverting. I don't know you are able to hear us or not.
Okay, perfect. So now I can hear you. So let's move. So here we are in the deployment part. So any doubt in the deployment, like the deployment segments, that
No,
different deployment
No,
segments?
it's good.
no,
It's
sir.
good.
Okay, perfect. So we talked about the SP3 architecture, right? The SP3 single pass parallel processing architecture. So in the single pass parallel processing, like Palo Alto overcome with the limitation of the UTM, where the traffic can pass directly in a single shot from the Palo Alto and utilizing all the features that are available in the Palo Alto, like the app ID feature, user ID, like all the features. The traffic will initiate from here, for example, it's your LAN segment, it hit the Palo Alto firewall. In a single shot, it process the traffic, and in between, it utilize all the filtering, like all the features which we enabled, okay, where we configured, like we configured security policies, we configured netting, we configured ACLs, and apart from that, app ID, content ID, URL filtering, all the features that is utilized here, and that is the line speed. Means that traffic is not going to be hampered or not going to be delayed. It is just passing as it is directly, and all the policies implemented on the traffic directly here without any delay. So this is the policy engine. It's showing app ID, user ID, content ID, networking, and the process of your traffic is happened. Single pass parallel processing. The name it implies its feature. Means all the processing will happen in a single shot, but parallelly. Single pass parallel means parallelly it is going to utilize all the policy which you configured on the Palo Alto. Let me tell you, there are basically two types of traffic. If you know how much type of traffic is there, can you tell me?
Control plane. Okay.
There are basically two types of traffic. Okay. The first one is to traffic. To traffic. Okay. The second one is the through traffic. Okay. So to traffic, the traffic which is distinct to the firewall interface only. This is to traffic. For example, user is there who is connected on the data interface and trying to ping its gateway, which is configured on the Palo Alto. Okay, so this traffic is not passing through the firewall. So this traffic is known as the to traffic. We initiated we initiated the ping request, and that request is hitting the Palo Alto firewall only, not passing through the Palo Alto firewall. But if we talk about through traffic, again, the same example, user is sitting here, and now that user is not pinging, that user is accessing something. For example, facebook.com. There is a server which is placed on the Google, on the cloud, right? Maybe on not cloud, we can say on the internet. And this is facebook.com. So this user is trying to access that facebook.com. This traffic is called as the through traffic because that traffic is passing through the firewall. Okay.
Sir, SSH and the telnet is the traffic that is to the traffic.
If you talk about SSH and Telnet, that traffic comes into the part of control plane.
Yeah. So it is initiated from the user.
User side, right? That is not hitting the interface. That if you talk about the Telnet or SSH, that traffic is not hitting the interface only or not passing the Palo Alto firewall, right? So that traffic cannot be the to traffic or through traffic. That traffic will be the part of control plane traffic.
Okay.
Okay. Just give me a second, guys. Just give me a second. Someone is there. You guys, I'm back. Sorry for the disturbance. Okay, so this is your to traffic where you are listening to the interface of the device, and if you are accessing something, and if that traffic passing through the device, that traffic is known as the through traffic. But if you talk about the SSH telnet, that traffic is the part of control plane traffic. That is not the to traffic, and that is not the through traffic. That is the part of the control plane traffic because your traffic is not distinct to the interface only, and that traffic is not passing the firewall. It is somewhere in between of the device, right? So that is the part of your control plane traffic.
Sir, so what are the traffic in the two traffic like the SNMP?
To traffic, just for example, if you are pinging, for example, from this user, if you are pinging that interface only, this is the part of to traffic. And if you are accessing something like, for example, timesofindia.com, that is not placed somewhere in the backend of the firewall, so that traffic need to penetrate the firewall, and that is the part of through
Through the traffic data plane is through the traffic, right?
data plane traffic. Correct. That
So
payload data.
VPN is the example of through the traffic, right?
Exactly.
Okay. Yeah.
So that policy basically, if you talk about the SP3 architecture, that SP3 architecture actually works more for the through traffic, not for the to traffic. If the traffic is not passing through the firewall, how we can implement the policies on that, right? So that SP3 architecture actually works on through traffic, and it's in the line is speed, all the policies, all the configuration implemented on the traffic which is passing through the firewall in a single shot, and it doesn't like put the latency on the traffic. The traffic will move from the firewall in just 1 or 2 milliseconds only. You cannot even observe the latency when the traffic is passing through the firewall. If that firewall is fully loaded, means you have enabled all the features that you have implemented all the configuration on the Palo Alto firewall, still you will not see any load, any time delay in the traffic processing. Okay. And separately, that control plane and data plane both are having their own CPUs and memories. Why that kind of architecture for this Palo Alto? Like your control plane, that management plane is having its own CPU and memory, RAM, you can say, and that data plane is also having its own memory and RAM. Why that kind of architecture is required? Let's suppose traffic is passing through the data plane, right? It's your data plane. Traffic is passing through the data plane, no issues, and the control plane is sitting as it is, no issues, everything is working fine. But suddenly, a cyber attack happened to your device. Your outside interface may be choked. They started the DDoS attack, denial of services attack. Okay, we'll talk about all the attacks in the later classes, just for the reference. So in the DDoS, the hacker started the ICMP hits on the outside interfaces, and number of hits on the outside interfaces, and that interfaces is totally choked, and you are sitting somewhere maybe outside, okay, and you are not able to take access from the outside. But if someone is sitting in the premises, he can directly take the access of the control plane, no issues in that. It means if your device is in the condition of a cyber attack, still you can take the access, you can take the control access of the device, and you can uh, like take the preemptive actions. You can shut the port for that time, or you can uh, uh, you can say that block that user's traffic. It's up to you. There are multiple things we can work on. We can easily shut the traffic, that interface for that time. Okay. We can easily shut that interface for that time. Or the second option is that we can block the that user, so that that user cannot hit the interface. Or we can configure the DDoS policies before that attack, so that hacker cannot penetrate the firewall, that hackers cannot choke the outside interface. Otherwise, my complete LAN network will be isolated. They have to use some other internet connections to take like services from the cloud. Getting my point? This is just for the reference. We are talking about the single pass parallel processing. This is a bit different thing. We'll talk about this in the later classes, because we have to do the labs on that. How we can protect our network from the DOS attack, from DOS or DDoS attacks. Okay. So here you can see, this is the general architecture of the Palo Alto. This is the control plane. This is the data plane. Both the planes are separate, right? But here control plane is having its own CPU and RAM. The data plane, there are multiple things in the data plane. Signature match is having its own RAM. Okay, SSL, IPsec, decryption. They all are the service engines, right? They are having their different CPUs and RAMs. So it means if your complete data plane is chalked, means you cannot access or pass the traffic from that data interface or data plane. Still, you can take the access of the control plane of the Palo Alto Firewall, and you utilize the preemptive actions at that time. That's why it create a difference in the network segment, because in other devices, if your device is stuck in the cyber attack, at that time you are not able to perform anything. At that time you are totally isolated. You just need to plug out the internet connections. Then after, you can take the access of your device and check what is going to be happen to your infra. But here in the Palo Alto, you don't need to plug out the internet connections or the LAN connections. You can take directly access of your control plane. Understood? Any doubt?
No, sir.
This is just for the reference. This should be in your mind. Like, if in future, if an attack happens to your device, still you can take the access of your device through the control plane. Okay, and you can perform the preemptive actions to protect your device and to protect your infra. So let's talk about the packet flow. This is something which is required for you to be in your mind, so that like when you configure something, when you configure the security policies on the Palo Alto Firewall, at that time, like, it should be clear to you, like how your packet is flowing, how your packet is processing through the Palo Alto Firewall. So this is the packet flow of the Palo Alto Firewall. Let's assume someone initiated a request and he wants to access the facebook.com. So the traffic comes to the initial packet processing state. Here, what happens? Firstly, the Palo Alto is going to check the source zone, source address, and source user ID. If we configure the source zone, or if we configure the source address IP, and if we configure any source user ID, we'll check about this, like this feature, user ID creation. This is required in the uh, remote access VPN. So we'll talk about this. So firstly, it will check the source location from where the traffic is coming. Okay. Then it will check the forwarding lookup. Means any forwarding table is created for that traffic, or if any PBF, policy based forwarding. We talked about this, right? If PBF is configured here on the Palo Alto, it is going to bypass all the security policies. It will directly through that like through traffic to that location, if that PBF is configured here. But if in case PBF is not configured, then it is going to check destination zone. Firstly, uh, this firstly it checks the source zone. Now it is checking the destination zone. Now the Palo Alto is clear, like from where the traffic is initiated and where it wants to go, where it wants to go out. So source zone and destination zone is clear to Palo Alto Firewall. Now it is going to check the net policy. It is just evaluating, not checking, not like implementing. It's just evaluating whether there is any net policy configured for this traffic, that source traffic which is coming from source zone this, and wants to move to the destination zone this, right? So we can assume this is your source zone, this is your destination zone. Okay, so Palo Alto is going to check. Palo Alto is going to check the source zone and the destination zone, and lastly it is going to check the net policy evolution. It is going to check the net policy is there for this traffic, for that initiated traffic. Okay, then Second thing come here, security pre-policy check. Security pre-policy. What checks here? Check allowed ports for the traffic. It is going to check the allowed ports. If we allowed some certain ports for the traffic, it is going to check that allowed ports. Then it will create a session. In the Palo Alto session table, it is going to create the session. Now the traffic comes to the application. Here it is going to check for the encrypted traffic. With it, well, like what's the difference between the encrypted traffic or the plain text traffic? Any idea about encrypted and plain text traffic? Have you ever seen on the, like, if you are
No,
saying
in
something?
the encrypted packet, no one read your data
Exactly.
when, when it travels from one location to another location.
Like if you are accessing Times of India, right? Let me open this Times of India, for example. So here you can see at the very beginning of that Times of India URL, there is a lock mark, right? Lock mark represents that traffic is encrypted, that traffic is SSL based encryption is already implemented. Once you click on this, connection is secure. It is showing connection is secure, means that traffic is encrypted. They are using some kind of encryption. We'll talk about this, but for now, for the reference, we can see it is showing connection is secure. There is a process in between where they are going to share the certificates from client to server, and based on that certificates, that traffic is going to be secure. That is HTTPS traffic. But if we talk about HTTP traffic, just one second. Hello. Guys, am I audible?
Yes, sir.
So this is Times of India. It is showing the secure mark as the connection is secure by the lock sign. Once we click on this lock sign, it is showing that connection is secure, means they are using some kind of encryption from source to destination, from client to server. Let's try to open this, my virtual machine. I want this. 31.135. 35. So here you can see I'm accessing my virtual machine that is directly connected, but still it is showing your connection is not secure. Why? because they are not using any kind of encryption mechanism in between from the client to server. In this example, my machine, my laptop is acting as the client, and he's trying to access something from the virtual machine, that is VMware workstation. So my laptop is acting as the client, and that VMware workstation is acting as the server. And in between, they are not using any kind of encryption mechanism. That's why it is showing your connection is not secure to this site. But in early example, where we are accessing the Times of India, example is same. My machine is acting as the client, and that Times of India server is acting as a server, right? But in between, they are utilizing something that so that the traffic cannot be hacked. No one can like penetrate that traffic. No one can check the traffic. What is moving inside that traffic? They are using some kind of encryption, but now they are not using. In this example, my system is not using any kind of encryption to access that VMware workstation. Okay. We enable wrong virtual machine. Okay, this is clear. Check for the encrypted traffic. Now, I think it's pretty much clear to you what is encrypted and how that encryption actually works in a broad view. If that traffic is accessing, like if we are accessing anything on HTTP, it means that traffic is not encrypted. And if we are using HTTPS to access any URL, at the time that traffic is going to be secure using some encryptions, right? So HTTP traffic is not secure. HTTPS traffic is secure. Same in that way, if we are talking about the remote access, okay? Remote access for configuration. So Telnet and SSH. What is secure and what is not secure in Telnet or SSH?
SSH is secure.
Exactly. Because for Telnet, as you can see, like if we talk about the configuration part for the Telnet, we don't need to configure the crypto, right? But we just need to enable that Telnet in the line VTY, and that Telnet will work. But if we talk about if we have to configure the SSH, then firstly we have to create the encryption bits. We have to create a domain first, then we have to create the encryption bits. Then after we can enable the SSH on a device. That's why SSH is secure. And recommendation is that you have to use HTTPS, SSH, not the Telnet, not the Telnet, not the HTTP traffic. That's why if we talk about our topics here, so by default, how much services are enabled or not enabled? Ping, SSH, and HTTPS. So here only SSH and HTTPS is enabled, not HTTP or Telnet. That's the reason. For the security purpose, they are not going to enable the Telnet or HTTP by default. Ping is required for the connectivity check, right? Ping is one of the basic tool to check the connectivity. That's why ping is there. Apart from that, SSH and HTTPS is there for security reasons. Okay.
Sir, if the traffic is initiated from the outside to inside at a first time,
Mhm.
so the packet flow will be same.
If you talk about the traffic flow, yes, obviously the traffic flow will be same.
From outside to inside at a first time.
Yes, obviously the traffic flow will be same, because that Palo Alto doesn't know which interface is connected to the internet and which interface is connected to the LAN. We configured the zones, right? LAN or LAN as inside, WAN as outside. We can give it any name: LAN, WAN, inside, outside, trust, untrust, whatever. Palo Alto doesn't know which interface is connected where, right? So traffic flow will be same if the traffic is coming from the inside or whether the traffic is coming from the outside. It is going to check all the things one by one. The source zone, then it will check the destination zone, then it will check the net policy. Then in the security pre-policy check, it is going to check the allowed ports. Then it will create a session.
Okay. Yeah.
Okay. But here, if you talk about the application, this is for the security, like it is the feature of the Palo Alto. Okay. So we can implement this application filtering app using the app ID. Here it is going to check the encrypted traffic. Okay. We saw there are two types of traffic, HTTPS or HTTP, right? HTTPS is the secure traffic, which is encrypted by some algo, but HTTP traffic is the plain text traffic. So it will check what type of the traffic it is. It is whether it is the HTTPS traffic or HTTP traffic. If that traffic is HTTPS, it means Palo Alto need to decrypt the traffic first, right? It is going to check the decryption policy, whether there is any decryption policy. By default, if we talk about the by default feature of the Palo Alto, if the traffic is coming from the LAN side and moving to the outside, here Palo Alto is able to check the traffic, right? It can check source and destination information. It can check source and destination information. But if the traffic is encrypted, Palo Alto cannot decrypt directly without the permissions. Are you getting my point? Like, same example, one user is sitting here and he is trying to access one side as HTTP, the second side as HTTPS. Now, the HTTP traffic, it is already plain text. So Palo Alto can easily identify what application user is trying to access, right? In HTTP traffic, Palo Alto can easily identify which application user is trying to access because that is the plain text traffic. But if we talk about HTTPS traffic, at the time that traffic is moving in a tunnel from source to destination. Okay. We'll talk about this because this is a different concept, but just for the general reference, Palo Alto can easily identify the traffic which is plain text. It means Palo Alto can easily identify the traffic for HTTP request because this traffic is plain text traffic. Palo Alto can check which application is passing through that traffic. But if we talk about the HTTPS traffic, at the time, source and destination is going to create a tunnel, SSL tunnel, right? And that traffic is encrypted. So Palo Alto cannot check what application is passing through that traffic because they already created a tunnel from source to destination directly. So for that, to check that kind of traffic which is passing through the HTTPS request, we need to create a decryption policy. We have to provide Palo Alto the authority to decrypt the traffic. Okay. If the decryption policy is there, Palo Alto is going to decrypt the traffic. Okay. If decryption policy is not there at the time, Palo Alto is not going to check that HTTPS traffic. By default, there is no decryption policy. So we can assume in a default parameter, in a default flow, Palo Alto cannot decrypt the traffic. We have to configure the policy. Then it will move to the application override policy. What is application override policy? That policy where if there is any application override policy means we can override the applications. This is for application, right? This check is for application. So here in the application override policy means it is going to override the application. Now finally it is going to check the app ID feature. Now Palo Alto is having the data of the application the user is trying to access. Now it is going to match that data with the applications, like what type of application it is. For example, again, user is trying to access the facebook.com, right? Now Facebook is HTTPS traffic. Palo Alto is going to check the encrypted traffic. Now it is going to check decrypt the traffic. Then after decryption, Palo Alto is having some data. It doesn't know what application is passing through the device. It just have the data. It decrypt the like data, the traffic, and it is having some data. And now it is going to match that data with its own application database. Okay. And then it will identify what application is passing through the firewall. So it's very simple actually. I'm not like, don't be confused here. It's very simple. Firstly, it is going to check the source zone, the destination zone, and then it will check the net policy the evaluation, right? In the second phase, it is going to check security pre-policy. It is going to check the allowed ports, how much allowed ports are there for that traffic. Now the session is created here. In the third phase, it is going to check the encrypted traffic. If that traffic is encrypted, then if that traffic is like not encrypted, we are using HTTP. At that time, there is no issue. Palo Alto can directly identify the app. But if that traffic is encrypted, it means HTTPS request is there. Palo Alto is going to check the decryption policy, and it will check the app. Understood? Any doubt till this application layer, application flow?
No, sir.
Now the traffic will move to the fourth part where security policy check. Now Palo Alto is going to check the security policy. Now Palo Alto is having the data information means it is having the application information, like which application is trying to pass through the firewall. Now it is going to check the security policy. In that security policy, we can allow or deny applications, right? We can allow or deny any traffic as per our requirement. We can allow or deny any port information. So it is going to check the security policy, whether that traffic is allowed or not. Then it is going to check security profiles. Both are the same part, security policy and security profiles. So it is going to check whether the traffic is allowed on the firewall or not in the security policy. Okay, if the traffic is allowed, the traffic will move to the final part where the post policy processing. Now, if the traffic is encrypted earlier and Palo Alto decrypted that traffic, so here Palo Alto is going to re-encrypt the traffic. Means if the HTTPS request was received on the inside interface or on the ingress interface, Palo Alto decrypted the traffic. Now it is going to re-encrypt the traffic here. But if that request was for the HTTP, means no encryption was there. So at the time, there is no re-encryption is there. Okay. If Palo Alto decrypted the traffic, at the time it is going to re-encrypt the traffic. If Palo Alto is not like decrypt the traffic, at the time, the plain text will move directly to the server. Now it is going to implement the net policy on that traffic and will forward the packet to the destination where the server it is. Maybe facebook.com, clientsofIndia.com. Good so far? Let me know if you have any doubt, any questions, any queries here in the packet flow.
No, sir. It's good.
You just need to read it for 2 to 3 times, then it will be in your mind, because it's not required actually for the configuration part. It's not required at the time, but if you are going to like uh, for the interview, at the time the interviewer can ask you the process, the packet flow, how the packet flow happens in the Palo Alto firewall. Okay, that is for the purpose for the interview only. Let's move further. So we talked about this. The by default management IP is 192.168.1.1, right? The password is admin by default. The user is admin. The password is admin by default.
Sir, I have one question.
Yes.
Can we make data port as a management port?
Yes. We no. Like if we talk about the management port, just give me a second. I'll show you the screen. Here is the view of that Palo Alto 220, the tiny one, right? So there are 3 different parts: the data interfaces, the management interface, and the control interface. Okay, you
But
can utilize that data interface to manage the Palo Alto firewall, but you cannot change the role,
okay.
because
Mhm.
role is already assigned to this interface for the management, right?
Right, right.
So on the data interface, by default, nothing is allowed. No services are allowed. Only like if it's your LAN interface, okay, and it's your WAN interface, for example. So by default, only if the user is trying to access internet and you have configured the security policy, that interface is going to transfer the data from here to there by default. You cannot ping that interface. You cannot uh, take access through that interface, but you can configure the management profile for that. Okay, and from using that management profile, you can take the access of that Palo Alto firewall. You can utilize that interface to manage the firewall, but you cannot change the role, because the management role is already predefined, assigned to this interface. Okay,
Mhm. Okay, fine.
we'll see that how we can use the data interface to manage the firewall. By default, HTTP, Telnet, SNMP services are disabled on management interface. Only HTTPS, SSH, and ping services are allowed. We saw that, right?